theoretical and actual velocities per hour, and the theoretical and actual cycle times, minutes per unit produced. Okay? So we have now the computador sa manufacturing plant in Des Moines that has the theoretical capability to produce 243,000 laptops per quarter but currently produces 91,125 units. The conversion cost per quarter is 7,290,000. There are 60,750 production hours available within the plant per quarter. In addition to the processing minutes per unit used, the production of the laptops uses 10 minutes of move, 20 minutes of wait, and 5 minutes of rework. And all work is done by cell workers. So for requirement number 1, we now compute for the theoretical and actual velocities per hour and the theoretical and actual cycle time, minutes per unit produced. So the theoretical um, velocities per hour is here we have 243,000. 243,000. That's the number of laptops per quarter. Then we divide it by 60,750 production hours available. So meaning we have 4 laptops per hour. The velocity actual 91,125. Amo na ang actualya per quarter. Divide it by 60,750. You have only 1 laptops per hour. So the cycle time theoretical is 60 minutes divided by 4 laptops, 15 minutes per laptop. The actual is 60 minutes divided by 1.5 laptops or 40 minutes per laptop. Question number 2, compute the ideal and actual amounts of conversion cost assigned per laptop. So we have now the conversion cost rate, 7,290,000. That's conversion cost per quarter. Then we divide it by the product of multiplying 60,750 production hours available per quarter, and then we multiplied that by 60. So we now divide 7,290,000 by the product of 60,760 multiplied by 60. So we get $2 per minute. Okay, $2 per minute. And the assignment per unit theoretically is $2 per minute times 15 minutes. So we have now $2 per unit times 15 minutes. So we now get 30 or 7,290 divided by 243. We now get 30. That's the assignment, theoretical assignment per unit. Okay, so in other words, we have now your um, 30 as the assignment per unit theoretical, but the actual is $80, multiplying $2 by 40 minutes. The last requirement of number 9, calculate MCE. How does MCE relate to the conversion cost per laptop? So we have now the MCE plus time divided by the sum of the process time plus the non-value added times. So we have now 15 divided by 50. So we have now the sum of 15, the process time, 10, 20, and 5 is 35 plus 50. So that's 15 divided by 50. So balang imo nga 15, amo nang process time. Ang 10, 20, and 5 are the non-value added activities time. So increasing MCE will reduce the actual press time by reducing non-value added time. This in turn will reduce conversion cost per unit. Now we go to exercise 10, cycle time and velocity. Refer to exercise 9 above. Assume that the company identifies poor plant layout as the root cause of wait time and move time. Express an improvement strategy as series of if-then statements that will reduce conversion cost per laptop. Now, in number 1, if the plant layout is improved, then wait time and move time will decrease. If wait time and move time decrease, then MCE will increase. If MCE increases, then conversion cost per unit will decrease. So, actually, you are just roaming around and applying the formula. In the case of requirement number 2 of exercise 10, assume that you can set an MCE target of 75% based on the improvement strategy described in requirement 1. What is the expected conversion cost per unit? Explain how you can use these targets to test the viability of your quality improvement strategy. So in requirement number 2, MC of 75% implies the following ratio. So that would mean 50 divided by 20, which implies that move time and wait time have been reduced to 0, leaving rework time of 5 minutes as the source of the inefficiency. The expected conversion cost per unit is 2 times 20 minutes or 40 minutes. This strategy can be tested by executing the performance drivers and seeing if the log variables achieve the predicted values. For example, if the company redesigns the plant layout, do move time and wait time reduce to 0? If yes, then does the applied conversion cost drop to $40? If yes, then evidence exists supporting the viability of the strategy. Okay, now we move to exercise 911 is still balance scorecard, lead and lag variables. Balance scorecard, lead and lag variables. Okay, now we have double loop feedback. The following if-then statements were taken from the balance scorecard. A. And you have the requirements after A to D. Identify the lead and the lag variables and explain your reasoning. Discuss the implications of requirement 1 for the financial and learning and growth perspective using the first if-then statement. Explain the concept of double loop feedback. So, in requirement number 1 of exercise ano na kita class 9-11. Okay, 9-11. Let's continue with the exercise 11. Here, lead indicators make things happen. They are the things that enable outcome measures to be achieved. Some measures may act as both lead and lag indicators. This exercise illustrates and emphasizes that it's very difficult to classify measures as lead or lag without expressing the underlying strategy as a series of if-then statements. If A, then B. If B, then C. helps identify the lead and lag roles of measures. When A is associated with a premise, it functions as a lead measure. If A measure is associated with a consequence, it acts as a lag variable. Kay kung mga lag, amo na ang previous, no? Ang previous, ang lead, amo na ang future. If B lead, then C lag. Thus, we have the following. Employee capabilities, lead indicator, press time, cycle time, lag as a consequence, and lead as a premise. Customer retention lag as a consequence and lead as a premise. Market share lag as a consequence and lead as a premise. Revenues now as lag indicator. In requirement number 2 of number 11, discuss the implications of requirement 1 for the financial and learning and growth perspective. In number 11, it's interesting to note that learning and growth indicators come at the beginning of the strategy. Map and dot indicators from the financial perspective come at the end of the map. Thus, learning and growth lead to act primarily as lead indicators. Okay, and financial perspective indicators tend to act primarily as lag indicators. This says that changing the financial outcomes is rooted in performance indicators coming from the learning and growth process and customer perspective. Now we go to question number 3, using the first if-then statement. So that's if employee capabilities increase and plus time decreases. Explain the concept of double loop feedback. Double loop feedback provides information about both effectiveness and viability. If employee capabilities do not improve, amo na nga aton nga if statement, then it could be due to one of two reasons. The targeted value for employee capabilities, number of targeted training hours was not achieved so the strategy was not implemented according to plan. Thus, even though the hypothesized relationship may be correct, the outcome wasn't realized because the levels planned for the performance driver were not achieved. So number 2, the planned level for employee capabilities was achieved, but cycle time did not decrease. This provides evidence that the hypothesized relationship is not correct and questions the viability of the strategy itself. Now, the next is number 12. It's testable map strategy, no? Testable strategy and strategy map. Consider the following quality improvement strategy as expressed by series of if-then statements. If real-time feedback information capabilities improve, then post-sales service time will improve. If